Welcome to the Deep Dive. This is where we really unpack complex tech topics and make them, well, usable for you. Today, we are diving deep into AWS GuardDuty. It's pretty foundational for cloud defense, wouldn't you say?
Oh, absolutely essential. The old ways of thinking about security like a castle wall, they just don't work in the cloud anymore. Everything's API driven now.
Exactly. That perimeter is gone. If you're still thinking network IDS like in the old data center days, you're probably missing the real risks.
You really are. The game has changed. The new perimeter, like the source material stresses, it's all about identity and access management, IAM. And honestly, traditional tools just choke on the scale and speed of AWS. They can't keep up.
Right, the dynamic nature of it all, things spinning up, spinning down.
Precisely, and that's exactly where GuardDuty comes into play. It's designed as that foundational continuous monitoring service. It handles the sheer complexity of processing just mountains of metadata daily.
Petabytes, apparently.
Yeah, petabytes. And it means you don't have to build and manage these massive log analysis pipelines yourself. It's basically your shortcut to smarter threat detection.
Okay, so our goal today for you listening is to really unpack this. We need to get past the buzzwords and understand how it actually works under the hood. The serverless part, the detection methods, ML versus threat feeds, and this big claim about slashing mean time to detect, MTTD.
Yeah, that 90% reduction figure pops up. It's a bold claim, and we need to see how realistic that is.
So let's start with what makes GuardDuty different. What are those core principles setting it apart from, say, older on-prem systems?
Okay, three main things stand out. First, and this is huge for ops teams, it's fully managed and agentless for its core function.
Meaning no software to deploy on your machines.
Exactly. No agents to install, patch, or worry about. It works independently, analyzing metadata from a separate stream. So critically, it doesn't slow down your actual applications.
That's a massive operational win right there. Just eliminates so much friction, especially across large environments.
It really does. Second principle. It's intelligent and adaptive. It's not just static rules. It uses machine learning, behavioral analytics, to figure out what's normal for your specific account.
Right, so it's tailored.
Yes. It spots anomalies, things that deviate from your baseline. That's how it catches novel attacks. Things that don't match any known signature yet.
Okay, adapts to your unique fingerprint. And the third principle, you mentioned synergy.
Integrated by design. This is key. GuardDuty isn't meant to be isolated. It plugs right into the rest of the AWS security ecosystem. Findings flow into Security Hub, Detective, Event Bridge.
For that automated response we hear so much about.
Exactly. It turns a simple alert into a potentially automated contained incident. It's about creating a cohesive security posture, not just point solutions.
All right, let's get into the nuts and bolts. The serverless brain. The documentation emphasizes scalability, efficiency.
Yeah.
How does GuardDuty actually handle processing, billions of events across the globe?
Well, it uses what they call a detector-based model. Since it's fully managed, it scales automatically behind the scenes. Think of it like this. For each AWS region you enable it in, there's a logical detector.
Okay.
That detector is the engine doing the monitoring for that region. And importantly, it keeps the data analysis within that specific region. So if your stuff is in London, the analysis stays in London. Huge for compliance.
And the beauty is you don't have to manually feed it logs, right? No complex setup with Kinesis or anything.
Correct. That's part of the fully managed promise. When you turn it on, it automatically starts consuming metadata from 3 foundational AWS data sources. And crucially, it uses a separate duplicate stream for this.
Why is that separation so important?
Because it means GuardDuty's work doesn't mess with your own logging setups. If you've got CloudTrail logs going to S3 for compliance or feeding into your own SIEM, GuardDuty doesn't interfere with that flow at all. It runs in parallel, invisibly.
Okay, that avoids performance hits and availability concerns. Let's break down those 3 foundational sources it taps into automatically. First up, the control plane.
Right, that's AWS CloudTrail management events. This logs basically every management API call made in your account.
Good.
Who launched what instance, who changed permissions, deleted a database, modified a security group, all that stuff.
And GuardDuty is looking for what, specifically, in those logs?
It's hunting for identity and access anomalies, often the first sign of trouble. For instance, a classic attacker move is trying to disable CloudTrail itself to cover their tracks. GuardDuty flags that API call immediately.
Makes sense.
It also looks for weird stuff like changes to IAM password policies or maybe API calls suddenly coming from a completely new country that users never operated from before. It's the who did what, where, and when layer.
Okay, that covers managing resources. What about traffic inside your network within the VPC?
That's where Amazon VPC flow logs come in. These provide metadata about IP traffic, not the content, just who's talking to whom between network interfaces in your virtual private cloud.
So looking for lateral movement.
Exactly. Things like a compromised web server suddenly trying to connect to a database it never talks to, or internal port scanning reconnaissance. It also checks if any internal IPs are talking to known malicious external IPs based on threat intel feeds.
So CloudTrail is who and why, VPC flow is internal network chatter. What about communication going out?
That leads to the third source, DNS query logs. GuardDuty watches the lookups made via the Route 53 resolver. This is incredibly valuable because almost all malware needs DNS to phone home for command and control or C2.
Ah,
So monitoring these DNS queries lets GuardDuty spot those C2 callbacks, which is a strong sign an instance is compromised. It can also detect data exfiltration attempts disguised as DNS lookups or communication with domains linked to botnets or phishing.
okay, so those three, control plane, internal network, external comms via DNS, form the foundation. But just collecting logs isn't enough. The analysis where the intelligence lies. So let's compare the two main analysis methods, machine learning versus threat intelligence.
Yeah, they work together, really. Think of threat intelligence feeds as the known bad guys list. It's signature matching, essentially. These feeds are huge, constantly updated by AWS security and third parties like Recorded Future. We're talking millions of indicators, malicious IPs, domains used for crypto mining, C2 servers.
So fast detection for known threats.
Super fast. If an IP is on the list, boom, it's flagged. Covers over 30 rule sets, updated hourly sometimes. It catches the low-hanging fruit very effectively.
But the limitation is it only catches what's already known, right? That's where ML comes in.
Exactly. Signatures can't catch 0 days or highly targeted attacks using clean infrastructure. That's the job of the machine learning models. These are custom built for your account. They learn your normal patterns, who logs in, when typical API call volumes, normal data transfer amounts.
So it builds a behavioral baseline.
Precisely. And it flags anomalies, significant deviations from that baseline. Even if the IP address isn't on any threat list, if the behavior is weird for you, the ML model will catch it. That's how you spot insider threats or compromised credentials being used in unusual ways.
Like my example earlier, if my S3 data transfer suddenly spikes tenfold at 4 a.m. on a Sunday, even from a legit IP.
The ML should absolutely flag that. It's an anomaly in terms of volume and timing, something a static threat feed would likely miss entirely. It's this combo global known bad list plus account-specific behavior analysis that gives GuardDuty its power.
Okay, makes sense. Now quickly on mechanics. Findings are JSON. What about compliance and data security for GuardDuty itself?
Security is built in. Findings are encrypted at rest with KMS and in transit via HTTPS. The standard retention is 90 days in the console, but yeah, for compliance like SOC2, PCI, APIDA, you absolutely need to set up long-term archiving, usually pushing those findings to an S3 bucket. Auditors want years of data, not just 90 days.
Right. And cost. All this monitoring sounds like it could get expensive, especially at scale.
Actually, the cost efficiency is a major plus. It's pay as you go, based mostly on the volume of log events analyzed. For those foundational sources, CloudTrail, VPC flow, DNS, it's incredibly cheap, like a fraction of a cent per 1,000 events.
Wow.
And because it's serverless, you're not paying for idle servers or managing infrastructure yourself. It scales with your usage, making security costs predictable and, frankly, pretty cost-effective compared to building it all yourself.
Okay, so the foundation covers the control plane, the network. But cloud workloads are diverse, right? We've got S3 data lakes, containers, serverless. GuardDuty has evolved with these optional add-on protection plans. Tell us about this modular approach.
Yeah, the foundational stuff gives you great visibility, but it doesn't see inside a container or know precisely what data is being pulled from S3. These extended plans are designed to provide that deeper workload-specific visibility where you need it most.
Let's start with S3 protection. Given how many breaches involve S3 misconfigurations or access issues, this seems critical.
It really is. Remember, the foundational CloudTrail management events only track who changed the S3 bucket policy. S3 protection dives deeper by analyzing CloudTrail S3 data events.
Ah, the object level stuff, like get object, put object.
Exactly. It looks at who is actually accessing the data. So if GuardDuty suddenly sees an unusually high number of GET object calls, maybe from an unexpected source, or right after a policy was relaxed, it flags that as potential exfiltration.
I see. It's watching the data access itself.
Right. And it also flags policy changes that might make data public accidentally. Plus, there's an add-on within S3 protection called malware protection for S3. This provides managed scanning of new files uploaded to specific buckets. Really important for stopping folks from using S3 as a drop zone for malware.
Okay, moving to containers and runtime monitoring, EKS, EC2, Lambda. This sounds more complex, described as a two-pronged defense.
It has to be two-pronged because attacks happen at different layers. The first prong is EKS protection. This is agentless and monitors the Kubernetes control plane by analyzing the K8's audit logs.
So looking for suspicious activity within Kubernetes itself.
Yes, things like someone trying to escalate privileges by messing with role bindings, or a service account doing something unexpected. It's watching the orchestration layer.
And the second prong, runtime monitoring, needs to go deeper into the actual host or container. This is where agents come in.
Correct. Runtime monitoring is about catching the attack payload executing. This uses lightweight agents deployed on EC2 instances or within your EKS worker nodes and ECS Fargate tasks. Now, there's an operational consideration here.
It's overhead, right. The documentation mentions 1-2% CPU.
Exactly. And we need to be realistic. For most workloads, 1-2% CPU is negligible noise. But
what if you're running, say, high-frequency trading or intense scientific computing? Is that 1-2% deal breaker? Do people just not enable it?
that's a fair question, and it highlights a real-world trade-off. In those extremely latency-sensitive scenarios, teams might hesitate. But the alternative is blindness. You wouldn't see malicious processes running, shell injections, weird file changes happening right inside the instance or container. A huge risk.
A massive risk. For the vast majority of users, that small overhead is a tiny price for catching malware execution or crypto mining at the source. Runtime monitoring is what sees the actual malicious activity happening on the OS level. Okay. And what about Lambda, the serverless functions? No agents there.
Right, you can't install agents on Lambda. So Lambda protection focuses on the function's network behavior. It analyzes the VPC flow logs generated by the Lambda function's network interface when it runs inside your VPC.
Looking for C2 again.
Yeah.
Or crypto jacking.
Precisely. Is this function suddenly talking to known bad IPs? Is it initiating unexpected outbound connections? It profiles the expected network activity of that function and flags deviations.
And finally, databases. Protecting the crown jewels with RDX protection.
Yes, RDS protection is specifically tailored for Amazon Aurora databases right now. It uses dedicated ML models to profile login activity. Who normally logs in from where? At what times?
So it builds a login behavior baseline for the database.
Exactly. This lets it detect sophisticated brute force attacks that might evade simple threshold alerts. It also flags anomalous logins, maybe from a strange location or an IP known to be used by attackers, helping protect that sensitive data, like patient records in healthcare scenarios.
The overall message seems clear. Foundational coverage is essential, but you really need to layer on these modular protections based on your specific architecture and where your critical assets live.
All right, let's really get into the intelligence engine now. How does GuardDuty turn all those logs into reliable alerts? It's more than just matching signatures. It's about that predictive behavioral side.
But let's focus on that behavioral baseline.
Yeah.
It's not just looking for bad IPs. It's about context, right? Detecting what's weird for you.
That's the core of the account-specific ML. It builds that unique fingerprint. What's normal activity in your dev account might be highly suspicious in production, you see.
Makes sense.
So anomalies could be obvious things, like an IAM user suddenly logging in from North Korea when they're based in Ohio. But it also catches subtler things.
Like unusual patterns of API calls.
Exactly. A sudden burst of activity trying to change permissions across multiple services. Or maybe creating a ton of new EC2 instances outside of normal deployment patterns. Or deleting backups unexpectedly. It also looks for data egress, spikes a sudden jump in data flowing out of your VPC or S3 buckets, which is often a sign of data theft underway.
But this internal baseline needs global context too, right? The threat intelligence integration.
Absolutely. And GuardDuty pulls from top-tier third-party, feeds the sources mentioned, recorded future, CrowdStrike. This keeps it current on emerging global threats, attacker TTPs, and malicious infrastructure. It's not just AWS's internal view, it's leveraging industry-wide intelligence.
And there's that crowdsourcing aspect you mentioned, the feedback loop.
Yeah, this is really powerful. When GuardDuty detects a new threat targeting customer A, say, a specific C2 domain, that indicator gets anonymized, validated, and fed back into the global threat intelligence.
So an attack on one customer helps protect everyone else.
Instantly. It hardens the defenses for all GuardDuty users. You benefit from the collective visibility across the entire AWS customer base. It's a powerful network effect for defense.
And users aren't just passive recipients, they can tune the engine.
Yes, definitely. You can add your own custom threat lists, IPs or domains you know are bad based on your own intel. GuardDuty will then specifically watch for or block traffic related to those. And just as importantly, you can add trusted IP lists.
For what purpose? Reducing noise.
Exactly, to suppress false positives. If you have known benign IPs for your internal monitoring tools or specific partner integrations, adding them to a trusted list tells GuardDuty, hey, traffic from here is okay, don't alert on it. Fine-tuning is key to managing alert volume.
Okay, so an alert of finding gets generated. How does an analyst know what to tackle first? That's the severity scoring.
Right, the scoring is crucial for prioritization. It's based on potential impact and detection confidence. You really need to understand these levels. Critical, 9.0-10.0 means stop everything. This is likely an active, successful compromise happening now. Think credential theft followed by malicious activity, needs immediate, automated, or human response.
And high.
High, 7.0 down 8.9, usually means a resource, like an instance or credentials, is compromised and being actively misused. Maybe C2 communication is confirmed. Action is needed right away to contain it, then investigate.
Medium is more uncertain.
Medium, 4.0 to 6.9, is suspicious activity, often a behavioral anomaly. Needs investigation to figure out if it's malicious or just, say, a misconfigured app or a developer doing something unusual but legitimate.
And low is just noise.
Not quite noise, but low priority. Low, 1.0 to 3.9, is typically attempted bad activity that was likely blocked. Think failed port scans or reconnaissance probes, useful for context, for understanding who's knocking at the door, but probably doesn't need waking someone up at 3 a.m. The whole point is to focus attention where it's most needed.
Let's switch gears slightly. A big concern with any powerful security tool is its own security. GuardDuty sees a lot of metadata. How does AWS ensure GuardDuty itself follows least privilege and can't be abused?
That's a critical point, addressed through service-linked roles, or SLRs. GuardDuty uses a specific IAM role, AWS service role for Amazon GuardDuty, to get the permissions it needs to access that metadata.
And how is that role locked down?
The key is the roles trust policy. It explicitly states that only the GuardDuty service principal, guardduty.amazonoz.com, can assume this role. No human user, no other service, not even root, can assume it. And the permissions within the role are tightly scoped just enough to describe resources, list buckets, get flow logs, etc. It can't, for example, read data inside S3 buckets or modify your critical infrastructure.
So the detection service itself can't become an attack vector.
Precisely. It's architected to prevent that. It's fundamental to trusting the service.
Okay, and finally on the management and compliance side, how does GuardDuty fit into frameworks like NIST?
Well, a GuardDuty finding, like spotting anomalous S3 data access, is a direct technical indicator of a potential privacy event under frameworks like the NIST privacy framework. It helps demonstrate you have technical safeguards in place supporting that protect function.
And for large organizations, managing this across potentially thousands of accounts.
That's where AWS Organizations integration is vital. You designate a central GuardDuty administrator account. From there, you can enable GuardDuty, manage configurations, set up trusted lists, and even view findings across all your member accounts without needing admin access in every single one. Centralized management is key for governance at scale. So GuardDuty finds the threats, but finding isn't fixing right. Its real power, its force multiplier effect, comes from integrating those findings into an automated response workflow. The goal is to shrink that mean time to containment.
Right back to the analogy, GuardDuty is the cop on the beat. The findings are the reports. Where do those reports go first for central command?
That central command post is AWS Security Hub. Think of it as City Hall. GuardDuty sends its findings there in a standardized format. Security Hub then aggregates these findings with alerts from other AWS security services like Inspector for Vulnerabilities, Macie for sensitive data discovery.
So it provides that single pane of glass Reduces alert fatigue.
Exactly. Instead of juggling alerts from 5 different tools, analysts get one prioritized view in Security Hub, helping them focus on the most critical issues first.
Okay, Security Hub flags a critical finding. Now we need the full story, the who, what, when, where, why. That's where Amazon Detective comes in, the chief investigator. How does it build that behavior graph from a GuardDuty finding?
Detective is like the relationship expert. It automatically pulls in the GuardDuty finding, then correlates it with related logs, the raw CloudTrail events, VPC flow logs, resource configurations, user login history, everything connected to that finding.
And visualizes it.
Yes, using graph database technology. So, if GuardDuty flags C2 traffic from an EC2 instance, Detective doesn't just show the alert, it maps out who launched that instance, what role they used, what other IPs did that instance talk to before the C2 started, were there any unusual API calls around the same time? It builds the whole attack narrative visually. Sources say this can speed up root cause analysis by up to 30%.
That time saving is huge. But the ultimate goal isn't just faster investigation, it's faster containment.
Yeah.
Getting that MTTC down from hours to seconds, this is the automated response chain.
This is where the magic happens for containment. GuardDuty findings are published as events to Amazon EventBridge in near real time. EventBridge acts like a smart router for events.
So you set up rules in EventBridge.
Exactly. You create a rule that filters for specific GuardDuty findings, maybe only high and critical severity, or specific threat types like unauthorized access, .ec2 malicious IP caller.
And when a finding matches the rule, it triggers.
It triggers an action. Most commonly, it triggers an AWS Lambda function. That Lambda function is your automated runbook, your script that takes immediate action. The whole process, from detection by GuardDuty to the Lambda function starting, can literally be just a few seconds.
Okay, walk us through that classic example. Automated quarantine of a compromised EC2 instance. How does that flow work in milliseconds?
Right, so GuardDuty detects, say, C2 communication, a high-severity finding. It publishes the finding event to EventBridge. EventBridge has a rule looking for that specific finding type and severity. The rule matches. Bang.
Triggers Lambda.
Triggers the Lambda function. The Lambda function's code reads the event data, pulls out the ID of the compromised EC2 instance from the finding's JSON payload. Then, using the AWS SDK and appropriate IAM permissions, the Lambda function immediately calls the EC2 API to modify that instance's security group.
Swapping it to a quarantine group.
Exactly. It assigns a predefined quarantine SG security group that's configured to block all network traffic in and out, except maybe SSH from a specific bastion host for forensics. The instance is instantly isolated.
Wow, that's containment in seconds, 247, no human intervention needed initially. That's the difference between an attacker getting a foothold and being stopped dead in their tracks.
It completely changes the game for incident response. It frees up human analysts to focus on the why and how the forensics rather than scrambling to just stop the bleeding. And you can get more sophisticated too. The Lambda could trigger AWS Systems Manager SSM runbooks
To do what?
to maybe take an EBS snapshot of the compromised instance's disk for forensic preservation before quarantining it, or gather specific logs, or even patch systems automatically based on the finding. And of course, notify the IR team, all automated, all triggered by that initial GuardDuty finding.
And CloudWatch monitors this automation.
Yeah, CloudWatch plays a role too. You can set up metrics and alarms on the volume of GuardDuty findings or the success-failure rate of your Lambda response functions. A sudden spike in high-severity findings might indicate a large-scale attack needing more than just the standard automated response, perhaps triggering a major incident escalation.
Now, it's worth saying, when GuardDuty is set up well with automation, you often don't hear about the incidents publicly because they get shut down so fast. The stories we do hear are often where GuardDuty flags something, but the response was slow or missing. Let's look at some real-world examples where GuardDuty played a key role, for better or worse.
A good starting point is crypto mining. The 2023 crypto mining campaigns were widespread. Attackers found ways to exploit misconfigured IAM roles, often on EC2, to just spin up huge numbers of instances mining cryptocurrencies like Monero.
How did GuardDuty catch that? What was the signal?
It was usually a combination. First, the threat intelligence feeds often flagged communication with known crypto mining pool domains or IPs that showed up in VPC flow logs or DNS logs. Second, the behavioral ML models flagged the anomaly of sustained, extremely high CPU usage on instances that weren't supposed to be doing that.
And the impact of catching it early.
Huge. Where automated responses were in place, Lambda functions automatically terminating or stopping those instances based on the GuardDuty finding organization saved potentially millions. The estimate we saw was over $50 million collectively just by stopping that unauthorized compute usage within minutes instead of letting it run for days or weeks. Lesson learned. Auto remediation is vital for cost control and risk reduction.
Okay, next example highlights the gap between detection and response.
Yeah, the MGM Resorts compromise in September 2023. It reportedly started with social engineering, leading to compromised IAM credentials. The key point here is that GuardDuty did detect the initial anomalous activity, the credential abuse, the unusual API calls associated with reconnaissance and establishing persistence. The alerts were there early. But the response wasn't fast enough. That delay between the alert firing and effective containment action allowed the attackers to escalate privileges and cause widespread disruption. It's a painful lesson. World-class detection is necessary, but not sufficient. You need tightly integrated, rapid incident response, whether automated or human.
Let's talk data theft S3. GuardDuty's S3 protection add-on seems designed for this.
And it's proving its worth. We're seeing ongoing S3 exfiltration variants, sometimes quite sophisticated, echoing the methods used in breaches like Capital One. Attackers might use SSRF flaws to pivot internally, find sensitive buckets, and then start downloading massive amounts of data.
How does S3 protection catch this?
It analyzes those S3 data events, the GET object calls, and uses ML to spot anomalous patterns. A sudden, massive spike in downloads, maybe from an unusual IP or IAM role, or targeting buckets that aren't normally accessed that way, that generates a high-severity finding. In several documented cases in 2024, this early warning prevented potential exfiltration of hundreds of terabytes of data.
Reinforces the need for that modular protection.
Definitely. And the strategic lesson is layering. Use S3 protection for the access monitoring, but combine it with AWS Macie to understand the sensitivity of the data being accessed. Knowing someone is downloading lots of data is good. Knowing they're downloading your most critical PII or financial data is much better for prioritization.
Okay, next up, databases, specifically Aurora with RDS protection.
A healthcare RDS brute force incident in 2024 is a good example. Attackers targeted Aurora databases, likely trying to get protected health information, PHI. They used credential stuffing, brute force, often hiding behind VPNs or Tor.
How did RDS protection help?
Its tailored ML models profiled the normal login behavior for those specific databases. When the attack started, even though the attempts came from constantly changing IPs, the pattern of logins, the velocity, the failures, maybe unusual times, deviated significantly from the baseline. This generated high-severity alerts much faster than a simple failed login count threshold might have. It highlights the power of behavioral profiling for database security, alongside enforcing MFA wherever possible.
And finally, the Container World EKS.
The EKS supply chain attack scenario from 2024 involved malicious container images being deployed. Now, EKS protection might flag the initial deployment via the K8's audit logs, but the critical detection often came later from runtime monitoring.
The agent inside the container.
Exactly. The agent caught what happened after the malicious container started executing unexpected shell commands, trying to download further malware, attempting to escalate privileges within the node's OS. GuardDuty's extended threat detection capability can then correlate these runtime events with earlier control plane activity, creating a higher confidence sequence alert. It shows you really need that end-to-end visibility from the orchestrator down to the running process.
These examples are powerful. Let's wrap this section with that strategic lesson from the fictional text miner case security, not just as defense, but as a business enabler.
Right. The text miner story illustrates this perfectly. GuardDuty detected the very early stages of a sophisticated, persistent attack targeting their core databases, probing logins, trying different credentials over days. Instead of just reacting, their security team used it as a live fire test.
How so?
They let GuardDuty be the eyes and ears, observing the attacker's methods in real time while simultaneously building and refining their automated response playbooks using EventBridge and Lambda. They essentially hardened their defenses during the attack, using the attacker's own actions to validate their containment strategies.
Building their Fort Knox under pressure. And the business outcome.
Because they could later prove their resilience, showing logs from GuardDuty and detective detailing the attack and demonstrating automated containment that achieved an MTTC of minutes, they used this as a competitive differentiator. They won major contracts, multi-million-dollar deals with DoD and healthcare clients who demanded rigorous, verifiable security assurances like SOC 2 and FedRAMP compliance. The lesson: Investing in proactive, demonstrable security can directly lead to new revenue and a stronger market position. It's not just about preventing loss, it's about enabling growth. Hashtag tag outro.
Okay, that was a really deep dive into AWS GuardDuty. It's clear that intelligent detection, tight integration, and especially automated response are the pillars of modern cloud security. So for you listening, let's boil this down to the most crucial takeaways: the action plan.
First and foremost, enable it's everywhere. Don't just turn GuardDuty on in your main production regions. Enable it in all accounts and all regions, even the ones you think are inactive. Why? Because global services like IAM can be attacked or abused from any region, and if GuardDuty isn't watching there, you have a massive blind spot.
That's a critical point. Second takeaway.
Automate for speed. Seriously, this is non-negotiable if you want real security value. Set up those event bridge rules and Lambda functions for your high-severity findings now. Test them. That automated quarantine capability is what transforms GuardDuty from an alerting tool into a genuine containment system. It's the difference between minutes and hours or days of exposure.
Automate. Got it. Third.
Integrate for insight. Don't let GuardDuty findings sit in isolation. Feed them into AWS Security Hub for that centralized view and prioritization across all your security tools. And leverage Amazon Detective when you need to do a deep dive investigation. Use the whole ecosystem together. That's how you get from alert to understanding quickly.
Enable everywhere. Automate for speed. Integrate for insight. It really shifts security from being just a cost center, doesn't it? Makes it more proactive, even a business advantage, as we saw with TextMiner.
Absolutely. And that leads to the final provocative thought we want to leave you with. The real proof of your GuardDuty setup, especially your automation, isn't waiting passively for a real attack. It's simulating one.
Testing it proactively.
Yes. Use tools, there are open source ones, like the GuardDuty tester, to simulate a high-severity event, like that C2 communication or a brute force attack finding. Can your automated workflow detect it via GuardDuty, trigger event bridge, execute Lambda, and achieve containment, like modifying a security group in under, say, 60 seconds? What happens when you actually test it today?
That's the real acid test, isn't it?
It really is. If you can't hit that near real-time containment target in a test, your response layer needs fixing, not just your detection. You need to validate that your automated Fort Knox actually works when the pressure's on. Go test it.
Fantastic, actionable advice to end on. Thanks for walking us through all that. And thank you for joining us on the Deep Dive.